today our topic is about the Lorentz transformation. As we have discussed, what is the Lorentz transformation? I have already explained when Michelson performed the experiment. That experiment shows that there is no phase shifting, or even if you rotate the Michelson experiment, or if the direction of the source is if we are changing the direction of the sources, okay, then according to formula for parallel, there may be for parallel, the velocity must be add or subtract, speed of light must be add, or perpendicular c square minus v square. But these kinds of there is no such kind of the observations were experienced during the Michelson experiment. And according to Michelson experiment, the if A is one observer, the speed of light is according to if there are two observers, one is moving along the, or if there are two observers and they have different, if you have two different observers and they measure the speed of light, they will be the same. Speed of light will be not a different far. And from doing calculations, x a square plus y a square plus z a square minus c a yes. फ्रेम ऑफ रेफरेंस का डिफरेंट होने से मुराद ये है कि फ्रेम ऑफ रेफरेंस क्या होता है, मतलब जिससे आप ऑब्जर्व कर रहे हो, जिस फ्रेम में आप बैठे हुए हो, तो जाहिर है अगर फ्रेम ऑफ रेफरेंस डिफरेंट है तो ऑब्जर्वर मीन इफ यू आर मूविंग टुवर्ड द सोर्स ऑफ लाइट, इफ यू आर मूविंग अवे टुवर्ड द स्पीड सोर्स ऑफ लाइट, मीन दे आर टू डिफरेंट थिंग्स. इफ यू आर moving orthogonal to the source of the light, even all cases speed of light, the speed of light will be remain the same. Okay. So different observer means different frame of, if different frame of reference mean observing or sitting on that frame of references. So different frame of reference means the different observer. Okay, and the same meaning. Okay. So x b square plus y b square plus z b square minus c b since speed of light is same, so this will be x a square plus only one possible. It will remain the same only in the case if C is same, then T will be a different. If you take a T same, then C will be a different. Okay, so if you are interested why this has happened, the calculations and proof of these formula is available on the YouTube. I will be shared. Okay, so we will directly write that is. X, Y, Z are a component. Yes, you are right. If there is R is X, Y, Z, this formula actually X, Y, Z is component. We know that is X component L square is Cat Brown notation. I have already explained that will be x square plus y square plus z square. But when we consider that speed of light is constant, then it may easily prove that this will be equal to. And I have proven this formula is proved and derived when we consider that speed of light is constant. Then this formula will be. When you observe the thing with the laser light, that experiment and this evidence and proof is available on the YouTube lecture. I will be sure. Okay. Okay, but because y b square plus z b square minus t tb square. Okay. So it means for all observers, if this is a component, yes, as if this is length, this result is for the A, this result for B, observer B, and that is the total length is constant. Okay. Invariant, not constant. Invariant means they will not transform. That means that are the same in this frame of reference and this total. If I say that this is L means this, these are the same. Okay, this is equal to this same. The same means if that is invariant, I have already explained that the length of vector always remain the invariant. So it means it represents the length of vector. Okay, so this is length observed in A frame. This is length observed in B frame. Actually, we don't use. Okay, this is L. B frame. Okay. Actually, in mathematics, we will try to avoid the confusion because these are the not tensor indices. Okay. To try to avoid the confusion, we represent the A without prime and B represent mean we are moving from unprime frame of reference to prime. Means that is not different frame of reference. Prime unprime mean A frame, B mean okay. So actually, if I say this is 1, 2, 3, X is 1, 2, 3, and this is 4. So that's so it's not mixed up with the different indices, tensor indices. This is because it is not, as I have already explained, that indices doesn't mean that are the tensor. These are not tensor. This is not tensor indices. This is the indices are the frame. This is the constant. So try to because we are interested to avoid the confusion because हमारा मूवमेंट मैथमेटिक्स इतना अच्छा नहीं होता बहुत से बच्चों का, तो उससे बचने के लिए वैसे तो ये लिखना कोई मसला नहीं, लेकिन बहुत से बच्चे गलती कर सकते हैं, वो टेंसर इंडिसेस को मिक्स कर सकते हैं दूसरे से. तो हम यूजुअली क्या करते हैं, we usually try to this A mean we are moving from L to L dash. A से B की बजाय हम लिख देते हैं प्राइम से अनप्राइम, सॉरी अनप्राइम से प्राइम. जैसे हमने पिछली दफा टेंसर में देखी है, ठीक। यानी अगर मैं अनप्राइम यूज कर रहा हूं तो जो प्राइम यूज कर रहा हूं तो उसका मतलब कहीं ये नहीं है कि आपको ये पता नहीं कोई डेरिवेटिव ले लिया कुछ ले लिया, मतलब इसका मतलब ये बी फ्रेम है और अनप्राइम का मतलब है वो ए फ्रेम, ठीक है। सो आपके पास जो है एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर माइनस सी टी स्क्वायर एक्स प्राइम स्क्वायर प्लस y prime square plus z prime square minus c t prime square. Got it? And this remains the this means these are the, I have already explained, this is L square, that means L prime square. Mean length will remain the same, conserved. As I have already explained, the length will remain the conserved. Okay. So, invariant, sorry, they will not change. For all frame of references, for all transformation, length will remain the unchanged. If I write in the Euclidean space, okay, we know that length is x1 square plus y square plus z square minus, length is x1 square plus x2 square plus x3 square plus x4 square, sorry, अभी आप उससे कंफ्यूज हो, x4 square, okay, yes. From comparing these x1, this may be write as x, y, z. If I consider that this is equation A and this is equation B, okay. From equation A, x, y, z minus ct this is equation A, this is equation B, okay. If we compare them, then x1 square will be x square implies that this will be x, x1 will be. Similarly, x2 will be y, x3 will be z, and x2 square is equal to y square, x3 square is z square, x4 square is minus ct, c square t square. Then x4 will be iota c. Okay, when we take square root of this will be iota and this will be x4. The remaining will be the same as we use in the R. These is component of the element of R cube as the usual space. Okay, and if we combine this is the Lorentz space. Okay. This completely is its element of the Lorentz transform. Now that is a 4-dimensional. Okay. This x, y, z, and this is, and we know that if this is A, this is IA, then that will be IB. Okay. Then that will make our angle 90. So, if I say that this is R cube, then this will be IC, and the angle between 90. So all these components will be independent from each other. This is R3, XYZ, they are making angle 90 with, and this will be the orthogonal with imaginary. So that's it. And as I have already explained that the covariant will be the complex conjugate. If I write it in the form of the contravariant covariant, that if I write it in the form of contravariant covariant, covariant is complex. I have already explained. But if you write in the contravariant covariant, you don't need to write it is understood that are the imaginary, means that is the so that x1, x2, x3, x4 means alpha is 1, 2, 3 and 4. Here will be a transpose in row x1, sorry, that is wrong. x1, x2, x3 and x4. These will be covariant and this will be a contravariant. Okay. And again, this is x, y, z minus ct, x, y, z plus ct. That is. Got it? Okay. This is sy minus ct. This will be sy. Okay. If I say that x4 is actually x naught, okay. If I replace x4 with the x naught, then as we know that L square, which is x alpha and s alpha, okay, that was x square plus y square plus z square minus ct here. Yes. And if I write this is x1 square plus and this may be write as in this way. If this is constant, I may write in this way x square plus y square plus z square. Yes, I may write it in this way. Mathematically कोई confusion नहीं है. And I say that this is x naught square. This is x naught. This is x1. This is x2 plus x3. I may write in this way. Okay. This alpha is alpha is 0, 1, 2 and 3. So now this is equal to this. Now it's okay. What is this? This is x0, x1, x2, x3 transpose column. Okay. And this is x1, x2, x3, x4. Okay. So now I think it is a simple. Okay. And this was minus ct x y z. this was, there is a transpose, this was CT X, Y, Z. Okay. Yes. Yeah. Okay. Thanks, Margaret. Okay. So, this will be equal to this. Okay. Okay. And this, why this is called the flat space? Because we these are the same physical properties at everywhere. So that's why, because there is no the symmetry is same like a flat. That's why that is defined as a flat space. So this is its covariant part, and this is its contravariant part. But why these are the signature minus plus plus plus? So this signature is defined as minus plus 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 signature. So this will be defined as a minus plus 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 signature. Got it? Because first component is minus and remaining all components are positive. That's why that is defined as a minus plus 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 signature. And we know that mathematically, if x square y square plus z square minus t square is constant, invariant. If it is invariant, what is the meaning? If we multiply minus 1 both sides, if multiply equation A, it means equation A. If equation A, if I say that this is equation A, and I multiply it with the negative sign, then CT square will become a plus, remaining become minus x square plus, minus y square minus z square. And when we multiply constant with the negative number, this will be a new constant. That will be also in various quantity. So this may be also defined as a name. Okay, constant. This is also constant. When we multiply constant with a constant number, the result will be not a same constant, but that will be a different constant, but that will be a constant. So this will be also a conserve. Okay. So now x alpha will be defined as CT minus x minus y minus z, and this x alpha will be defined as CT x y and z. But signature will be with minus, plus, minus, minus, minus. I have used the transpose. When we write it in the form of, here it is, we are taking the transpose. Okay, so this is actually we are taking the transpose. So this is x naught. यहाँ भी इसका अगर आप कंपेयर इसके ऊपर भी ट्रांसपोज है, इसके ऊपर भी ट्रांसपोज है. अब कंपेयर करो तो x नॉट विल Okay, so this will be with the, now we will use these signatures, plus, minus, minus, use. Okay. Actually, you are a mathematically genius, so we don't need to write plus, minus, minus. Actually, we may say that this is R cube and this is the fourth not component. Okay, so there are two parts, the component, and this is usual space. All Laplace as R3. Okay, this is so I may say that the x alpha is actually x naught. This is subscript, then this is subscript, and xi, because all xi has the same properties. May I write it this? Okay. And I will prefer to write as minus Ct. Some books write xi, some books वेक्टर नोटेशन भी यूज कर लेते हैं, जैसे कि हम एफएससी में यूज करते हैं. Yes, I mean alpha mean 1, 2, 3, 4. I mean 1, 2, 3. Okay. X, Y, space. And टाइम बचाने के लिए, पता नहीं इतना टाइम बचता है या नहीं, मतलब ज्यादा लंबी कैलकुलेशन में तो ये काफी टाइम. And this X alpha is Ct. Okay, got it? So now the dimension is 4. X0, X1, X2, X3. So that's why that's defined 4-dimensional space. But it is about the flat space, not about the curved space type. In the curvature, we are not considering any type, because everywhere we are considering that there are 3 reals and T is orthogonal to imaginary. Okay, that's why that is defined. And in this case, this is as usually you define that these are the 3-dimensional space x, y, z. Nahin. Okay. Okay. This is x, y, z real space. मतलब आप frame of reference ऐसे ही define करते हो ना. Origin is O. ये all are making angle. Contravariant Ct, positive, covariant, yes, sorry, ये मैं सिग्नेचर हमने दूसरे लिए हैं, हाँ, yes, you are right, okay, ठीक, वो सिग्नेचर दूसरे के साथ मिक्स हो गया, मैं पुराने सिग्नेचर, ठीक है, okay, got it. Now the ये सिग्नेचर थे, sorry, मैं सिग्नेचर को दूसरे ले रहा था, प्लस माइनस, okay. Okay, got it. So x, y, z is a real dimension space as, and this phi is making angle phi. Okay. Okay. When in notation case we have studied that if it move toward this will be a translational transformation. If we are changing in origin, if you move from O to O prime, please be silent. X, Y, Z. Okay. Now this is sidebar. X, Y, Z. Now this will be a sidebar. I mean, if this is psi A, this will be psi B. Okay. And like a last rotation. Okay. And there are two transformations we have applied. We have applied two transformations. Yes. Which one? One was a rotation. One was rotation. Angle क्या लिया है? Angle but this phi is constant, but actually the frame is rotating. The angle is theta. Okay, I'm considering the rotation, and rotation have transformation in two indices ij. I is 1 to 3, j is 1 to 3. This will ij. I is 1, j is where I is equal to 1, 2, 3. Mean as I have already explained, 1, 2, 2, 3, 3, 1. Okay. J will be 1, 2, 3. Okay. And the other transformation is नहीं, मैं अभी बताता हूँ सारा बात. ठीक है. So this is Rij A, or the length is, this length is the displacement will be of the origin will be A. There are two types of translational. A will be translational transformation, and this will be a rotation. Okay, got it? I and J. You mean this is in Ij means 1, 2, 3, X, Y, Z. But now you have not a 3-dimensional space but 4-dimensional space. Now this was the regarding previous lecture. Now I'm combining the previous lecture with the new lecture. Okay. There is the 4-dimension that is iota CT. That was orthogonal to इस तमाम स्पेस से 90 एंगल बना रहा है. जितनी भी स्पेस है, ये नीचे प्लेन है और ये प्लेन के ऊपर था. तो दैट इज द ICT. So now this is transformation is in a 4. Okay, and this rotation will be converted into the rotation in a 4-dimensional space. Yani now here was this Ij, now this will not Ij, this will be a this rotation is represented by this transformation gamma cap. Okay. And this will be this have one is rotation, mean it if that is angle theta, depending upon the theta, and the other is A. And the length will remain the this phi, and how it will transform? Phi square will remain the phi, as I have already explained in the topic of the rotation. If you remember the topic of the rotation, that is correlated. Rotation was in a 3 dimension and it is in the 4 dimension. Okay. Yes. Now it's that is also like a rotation. That is also a rotation, but now it is in a space time. Okay. Time. This become a new dimension. Okay. 4 dimension. Now the dimension is 4. X0, x1, x2, x3, and x0, x1, 2, 3. So this is, and this is along the imaginary. Okay. Okay. Yes. Yes, you are right. That's why you may ask the question that may be confusing for you. If vector length is constant, then what is the length contraction? The answer is 0. That. Length is nahi samajh aayi. The dimension is 4. Length of 4 vector is conserved. X, Y, Z are components. One component. That is not in relativity in 4-dimensional space. There are 2 components. One is related to time. One is space. So that length contraction is one transformation of one component, not whole vector. Whole vector is combination of x0 square plus x1 square plus x2 square plus. That will be conserved. But x1, x2, x3 are not length of vector, but actually the 3-dimension component of the in 4 dimension. That is the component that are not actually the length. Okay, got it? Mean they have a 2 parts. They have a 4 component, x0, x1, x2, x3. Actually component is changing in such a way that length remain the preserved in the 4 dimension. Mean if the space length is contracting, there will be a time dilation. Mean one component is going to reduce, then other component will be increased in such a way that total length of vector will not change. Vector is defined whose length can never be changed. Okay. So that's the concept of the 4 dimension. Okay. So when you move from x alpha to x beta, okay, then x beta firstly I must write the topic. That's why the transformation of contravariant. Contravariant. So firstly I will define how the contravariant transform in Lorentz transformation. If we consider only the 4-dimensional space, I mean if we have a 4, if we are moving from x alpha to, let's suppose, xa, then xa will be, there is transformation as I have already, that will be transformed. One is rotation, and one is translational, and this will be Xa. No, sorry. What is was previous data? X alpha. Now the transformation is defined. हमने पर्टिकुलर केस ले लिया, हमारे पास कंट्रावेरिएंट कैसे ट्रांसफॉर्म होता है. Actually that partial x generally represent this by rotation. Okay, now we have divided it into the two parts. One is कौन सा? नहीं, alpha. If you take I of j or k, that will represent the 1, 2, 3. Mean x, y, z. Okay. If you are considering the alpha, beta, gamma, psi, psi, and the strange indices, then that will be represent the 4 vector 0, 1, 2, 3. Got it? Gamma, that is rotation in 4 dimension. Gamma. ठीक है, Lorentz Transf. X alpha, this is rotation. Okay, this a contravariant. Covariant. And what type of indices come here? कौन सा indices आएगा? All indices must be same. Which one indices must be same in each term? A. Okay. A must be same in. This is I distance. Okay. So alpha is contracting with this alpha is yes, this A. This rotation is 2 indices. Okay, one is contravariant, one covariant. Covariant will be contracting with the column will be contract with the row. Yes, A. If you are confusing this, time being you may replace this is a beta. मैंने तो आपको बताया ना किसी भी indices से represent. If you are confusing with this, you may say that this is a beta. Okay. एक मिनट बेटा. आप ठीक है. अब तो A क्या पावर A ना लगे ना आपको. ठीक है. मैंने आपको बताया था कि free indices will be same in each term, and alpha column must be contract with the row. So all will be because all was alpha must be contract, and that will be this will be. इधर नहीं, ये ट्रांसफॉर्मेशन है. ट्रांसफॉर्मेशन के बाद ट्रांसफॉर्मेशन रोटेशन वाला चैप्टर अगर आप देखो ना दोबारा, मैं आपके साथ वो लेक्चर अपना दूसरा भी शेयर करूंगा. मैं दोबारा बता देता हूँ. ठीक है. इफ वी मूव टुवर्ड दी if we consider that psi, मैं दोबारा psi when psi was transformed into psi under rotation theta 1 2। मैं प्रीवियस लेक्चर को दोबारा थोड़ा सा हिंट देने लगा, ठीक है, जिसकी वजह से आप कंफ्यूज हो रहे थे। इसके बराबर लिखा था 1 2 x y एक्सिस में मैंने ली थी, याद है। तो दिस वाज psi वाज r 1 2 थीटा psi था। एक मिनट बेटा, रोटेशन के साथ सिर्फ रोटेशन। दिस वाज, मैं बताता हूं वहां क्यों आएगा वो बताने लगा प्लीज। अब मैं आपको बताता हूं, ना समझ आए तो दोबारा पूछ। ये ऐसे लिख, ऐसे था, ये क्या था, cos थीटा माइनस साइन थीटा 0 साइन थीटा cos थीटा 0 0 0 1। This was psi x, psi y, psi z, ये था, ठीक है। ये क्या था आपके पास 1 1 1 2 1। This was the rotation method. This is rotation matrix. ये क्या था, r1 2 थीटा r r1 1 थीटा 1 2 थीटा r1 3 थीटा, फर्स्ट रो फर्स्ट कॉलम, सेकंड रो फर्स्ट, r2 1 थीटा। ये लीनियर अलजेब्रा का सारा जो है ना पार्ट है, ये वाला जो मैं आप बता रहा हूँ। असल में मैं समझा था कि आप पढ़ के आए होंगे। r3 1 थीटा r3 2, that was equal to this। ये था 1, ये 2, ये 3। In the form of column indices, this was this, this was this, in the form of, from here you may see that psi 1 is r11 theta psi 1 plus r12 theta psi 2 plus r13 psi 3, ठीक है। Similarly others, okay। So from here you may say that if psi is alpha, sorry, these are the in the 4 dimensions, that if that is I, this is R, this and this is must be same everywhere, okay। 1 1 that be, if that is 2 2 2 2, okay। So this will be I, the other will be a J in summation. J is changing 1 2 3 and psi J. Because J is dummy indices, I don't need to write. This is this. This was in a 4, and now R is replacing because now R is replaced. So this rotation is 2 and this will be multiplied with the transformation vector, okay, and translational transformation will be without that, there will be no this. Okay, got it. These are actually mapping of the 3-dimension rotation into the 4-dimension. Now got it? Okay. Ij, there will be summation on this. Okay. But now in 4-dimension that transformation will be like this. Okay. This is transformation of contravariant. Okay. Okay. 1 minute. If his column is transforming, this was the the column was transforming, row indices. If the column indices is changing, mean row is transforming, then how it will be transformed? कोई करेगा इधर आके? कोई ट्राई करेगा? ठीक है. आपका ओल्ड क्या है? ओल्ड के नीचे लगा दो ना. ओल्ड ये क्या है? बीटा. नया आपका ये आया. ओल्ड क्या था? अल्फा. ये आप गलती ना करो कभी. यहां मैं भी ऐसे लगा देता हूं ताकि ये याद रहे. ठीक है. मुझे भी लगाना चाहिए था. ठीक है. यहाँ थैंक यू. आप ठीक है. ये हमें यहाँ भी लगाना चाहिए था. ठीक है. मतलब ये और ठीक कर लेना. ये जो है ये आपका न्यू है, ये आपका क्या है? ओल्ड है. अब क्या आएगा आपके पास? x सेमीकोलन बीटा इक्वल टू गैमा x. आप उसको ना लिखो पहले, मैं आपको बताऊं गलती इस वजह से. आपने पहले क्या लिखना है? जो चीज है वैसे लिखना है. अल्फा प्लस ए ये लिखना है. ठीक है. ओके. अच्छा, अब क्या है कि बीटा आपका फ्री इंडिसेस है, तो ये सब टर्म में ऐसे ही आना चाहिए. ये कॉलम है तो कॉलम आना चाहिए. ये कॉलम है तो ये कॉलम आएगा. ठीक है. बाहर नहीं, इधर नहीं बाहर लगा. ठीक है. ये आ गया. और यहाँ क्या आ जाएगा? ये कॉलम है तो ये रो होगा, ये रो है तो ये कॉलम होगा. वहां ये कॉलम था, लेकिन क्योंकि एक कॉलम होता है एक रो होता है ना, 2 इंडिसेस है तो एक कॉलम होगा एक रो होगा. तो ये क्या होगा आपके पास? अल्फा. अच्छा, यहाँ क्योंकि आपके पास बीटा ही आना चाहिए, ये सब. और यहाँ क्या आएगा इसके ऊपर? यस, दिस विल बी अ सेमीकोलन. अच्छा, इज इट राइट? टाइमिंग ठीक है, पहली दफा आप लिख सकते हो, बट इट इज नॉट करेक्ट. इसमें भी मिस्टेक है. व्हाट इज द मिस्टेक? This is contracting with this. और जो कंट्रैक्ट करता है उसका कॉलम जो है शुरू में होना चाहिए. So that's means come here. ठीक है. नहीं, लेकिन शुरू में आप ऐसे लिख लो ताकि ना गलती ना हो. ठीक है. फिर आप इसे इस तरह, दिस विल बी okay. Now column is contracting with the column, the column is contracting with the row, and this column. Acha. Now the free index is column and beta, column beta. Free at every आपने चेक करना आपने काम सही किया या गलत किया है. तो अब देखो फ्री इंडिसेस बीटा है और वो कॉलम है, दैट मस्ट बी प्रिजर्व, मतलब दैट मस्ट बी सेम इन ईच टर्म एज इट गिवन इन द रिजल्टेंट. Okay, so this is the transformation of the contravariant. Okay, got it? 1 minute, covariant की कारण फिर ब्रेक. Now how the covariant will be transformed. This was the transformation of contravariant. Trans of covariant. That will be x alpha to x beta and L. Okay. The same. Now it is very simple. Okay, the same as, so x beta prime will be equal to, this is A. Okay, सबसे पहले आपने ये लिखना है ओल्ड क्या है, सेम क्या है. Yes, beta. Okay. Now this alpha must be contract with the other indices. So this will be transformed in such a way. Beta. Firstly, you write the indices. What are the free? Beta. Yeah, these are the free. If these are row, this will be a row. This will be a row. After that, this was old. It must be contract. This is a row. Then this will be contract with the column. Row will be contract with the column, and column will be contract with the row. Okay. So this is row indices, so that must be contract with the column. Similarly, in this case, that was beta, and this was alpha. Alpha must be this is a column, so this will be contract with the row. So then, हाँ जी. तो ये because इसको पहले आना चाहिए था column जो contracting column है. Then, okay. I think that is a very simple. Yes, no, not difficult. Okay. Okay. So next topic is so these were the transformation of contravariant and covariant. Okay. both mean if we now understand how the contravariant will be transformed into contravariant. If that is row, how it will be transformed. If that is column, then how it will be transformed. Now next is transformation of contravariant to covariant. If you move from contravariant to covariant or covariant to contravariant, then what will be happen? Okay. In contravariant to okay. Contravariant to now there will be no because frame of reference is same, so, but we are moving from covariant to contravariant to covariant. Okay, contravariant to covariant. How it will be transformed? There is a transformation. Okay, x beta will be. This is new, this is old. This transformation is defined as J. Okay. X alpha. X alpha. Okay. Okay. Beta and alpha. Column is contracting with row. Okay, got it? And yes, covariant. Covariant, subscript, superscript is contracting with it. Okay. This is transformation matrix. Yes, and that's good. This is transformation matrix. Okay, as rotation. Okay. It is defined as flat matrix because we are dealing with the flat space tensor, so that's why that is defined as a flat matrix. That is actually defined as a matrix, but for flat space that will be defined as a flat matrix. Okay. Okay. What is the G? We will try to verify it, but firstly I am interested to write only the transformation law. Okay. Flat matrix. Okay. Okay. Row will be transformed into column. Okay. Row will be transformed into row and column transform into column. Okay. X beta. Okay, so this is column. Here it must be a row. It is column. Okay. So indication must always, but it must come here. No, yeah. When you are transforming contravariant covariant, actually you are remaining, you are living in the same space. That's why we will not use the prime. Okay. This alpha is column. This will be contract with the row, because old way now the beta is free indices and column. Okay. Second indices will be a column indices. Oh, no, sorry. Okay. Got it? Now the question is, what is J? That is flat matrix, yes, but what are the values of? One minute. Yes? Beta is row. Alpha is column, is contracting with the row. Oh, sorry. Row is contracting with the column. Column indices. Alpha. This is okay. Again, I repeat it. If you are moving from contravariant to covariant, yes, covariant to contravariant, alpha to A, okay, alpha to A, that must be a different. आपने वो जो अभी 2-3 बच्चे पूछे थे कि नहीं ये हमारा तो हमने तो वही कर ये indices you must know okay what are the indices how they are transforming. Alpha is converting into A, that are the different. Okay, let X A is G X alpha, and this alpha is row, so and this is A alpha. Okay, and this is firstly right, it's left is row L is contracting. So this will be this, and if this is alpha to X A no sorry column must be contract with row. Column must be contract with row. Okay, sorry. This is was alpha. 1 minute. G X, this is A alpha column row A. Yes, alpha A. Column is contracting with row, and this column. Second indices. Yes, this is free indices. A is free indices. Second semicolon is nothing else, only it is telling that is second indices. Here A is second indices. This is second. I know it is very clear that alpha is first, and here it actually alpha first and A bar. Alpha first, A bar. But because actually this is row is contracting with the column. Actually, column must be contract with the column must be come before. So that's why it must come here. Okay. Here alpha is contracting. This here is row. ये row था. Alpha is contracting with the row column. Here this is column. This is column. So this will be contracted with row. Column will be whenever you multiply by A and B two matters. M, N, and P. Column indices must be the same. If here is a row, then here is a column. That's why this is column. This must be a row, and it must be come before. नहीं, कोई नहीं हो सकती, यही होगी, इसके अलावा कोई नहीं.